Hey, welcome everybody to lesson 3 of Unit 3, Solving Quadratics. You might notice that it says Part 1. That's because we're going to be breaking this up into a couple of parts. In fact, when it comes to solving quadratics, we're going to be looking at like 4 or 5 different ways that we can do that. I'm going to be introducing you to the kind of general ones right here, which would be factoring. So let's get right to it. When we're talking about solving quadratics, we're talking about things such as roots, solutions, or zeros. These things are all the same. They're synonymous with each other. So if you see any of these in the instructions anywhere along the lines, you need to know that these are all asking for the same things. They're asking for the solutions to a quadratic equation. They are also the place where they're the x-intercepts of a parabola, meaning it's where it crosses the x-axis. This is critical for so many things. I really can't get into how many different things you can get. I'll just give you like a taste. Physics, where do things land after a certain amount of time. You can go into heat over time. There's all sorts of stuff, right? Fire science is what I was looking at just then. But you can do so much stuff with quadratics that we really need to know how to solve and figure out where our solutions lie. Okay, so if we're looking at these graphically, we have a couple of different scenarios here. We can have two real solutions where our parabola crosses the x-axis twice, right? Notice your vertex is right below the axis and it's opening up, hitting twice. We could have where our vertex lands right on the axis, giving us one real solution. And then finally, our vertex is above our x-axis and then opening up. It doesn't cross at all, so we have no real solutions. Now, I just want to make sure that we're clear. This could also work upside down for all these situations. Okay? What's going to be interesting is we notice here that it says real solutions, right? 2 real, 1 real, no real. Later on, I think it's lesson 5 or so, we'll talk about things called complex and imaginary numbers, where we'll notice that we'll have some of those solutions show up here. Okay, so let's start working on how we can solve these things. One way to solve a quadratic equation is by putting the function into factored form and setting each piece individually equal to 0 and then solving. So if we can get our quadratic equation from standard form into this form and then set each of these individual pieces equal to 0, then we can solve. Okay? Here's how that works, by the way. What we're looking for, because this is all multiplication, what number would we have to plug in to x to make this number become a 0, so when we multiply, all of these things become 0. Okay, and that would happen here as well. So there could be 2 different numbers that would make this become 0. Okay, we're going to be looking at our first method right now, which is just general old factoring. Okay, general factoring will be our first method. 2 numbers that multiply to create the C value and add to make a B value, including signs. I believe that there's a lesson on this back in the review unit, but let's go over this anyways. We want 2 numbers that multiply to 14 and that add to -9. Now, back in the review unit, I gave you a trick to figure out, if I have a positive here and a negative here, it kind of helps us as far as what signs we need to use. Okay, I know I'm going to have an x, I'm going to have an x. This is positive and that's negative, so they're both going to be negative. I need 2 numbers that multiply to 14 and add to 9. How about 7 and 2? 7 times 2 is 14. 7 plus 2 is 9. That was pretty easy. That was the factoring part. Here's the only thing that's different from what we've done. From what we have done in the past. Okay, we're going to set each piece equal to 0, and then solve. If I add 7 here, I'll get the solution for this first piece, x equals 7. And over here, if I set x minus 2 equal to 0 and add 2 to both sides, I will get x equals 2. Those are our solutions. Visually, it's where it's crossing, right? 2 and 7. I know that that's not where it is on this picture, but that's what it would be on an actual graph for this equation. Okay? Let's try another one out. Alright, we have x squared plus 6x minus 27 equals 0. I know I'm going to have an x times some x. I need two numbers that multiply to 27 that add to 6. Because this is negative, I know I need to have one positive and one negative, but I want the larger one to be positive. So if I use 9 and 3, 9 times 3 is 27. And then the larger of those two is going to be positive, because positive 9 minus 3 is 6. Okay? We take each piece at this point, set it equal to 0, and then we'll solve. I'll subtract 9 from both sides, giving me negative 9 as one solution, and we'll add 3 on the other one, giving us 3 for our second solution. General factor. Two more to go over with you. Alright, we have x squared. Oh, by the way, I don't know if I bothered to even do this with you, but the directions, I've been changing them up. If you read it, it says roots. This one says solutions. This one here says solve, roots, zeros, solutions, right? So if you notice, all of our directions, it might say different things here, even on these ones from the last page, right? Solve, find the root. It's all the same thing. We're doing the same exact thing, okay? So I did that on purpose. I forgot to mention it earlier, but I have all those directions up here so you know it's the same thing. Anyways. Two numbers that multiply to 77 that add to 18. That's pretty easy. How about 7 and 11? We'll set each of those equal to 0. And then solve. I'm getting negative 7 for our first one. Subtract 11 on both sides, and we'll get negative 11 for our second root. One more for you. If we have this situation right here where we have an a value, if possible, we want to see if we can factor that out first. That means that each of these terms in this function have to be divisible by whatever that a value is. And it's not going to disappear. We're just going to pull it out and in front. 21 divided by 3 will give us 7. And 30 divided by 3 will give us 10. Okay, so I factored out that 3. You might remember earlier I showed you it said a times x minus p and x minus q, right? So that would be the little a that was in front. Now, that doesn't have any effect on the rest of our problem, really. I'm going to just keep it coming along with our work, but it's not going to make much impact on the rest of the problem. Two numbers that multiply to 10 and add to 7 are 2 and 5. And then we'll set these pieces. We don't really care about the 3 at this point, but we'll set these pieces equal to 0. Then we'll solve. Subtract 2 for that first one to get negative 2. And then subtract 5 on the second one to get negative 5. Okay? General factoring. So you've got 4 here to try. If you pause the video and do all 4, we'll go over all 4 at the end all together. When you're ready, just press play. Alright, let's check it out. Our first problem, two numbers that multiply to -42 and add to -1. Well, let's see, I need to have one positive, one negative. The larger number has to be negative, so I'm thinking 7 times 6. And then we'll take each of these pieces and we will set them equal to 0. You should have gotten -6 for one and +7 for the other. Your second problem, hopefully you noticed that you had a value in the front that you could have factored out. 16 divided by 2 becomes 8, and 30 divided by 2 becomes 15. Now we can factor this remaining quadratic. Two numbers that multiply to 15 and add to 8. I'm thinking 3 and 5. And then we'll set each of those equal to 0 and solve. Got -3 for the first one. And then if we do the second one, we should get -5. Okay, so far we've gone through two of them. If you've got anything wrong in here, go back, check your work, see where you made those errors. You don't want to make those errors again. Best way to not make those mistakes again is to identify them early. Okay, two more to go. Two numbers that multiply to 50 and add to 15. How about 5 and 10? We'll set both of those equal to 0. And then we'll solve. We'll subtract 5. I guess -5 for one of them. Here we'll subtract 10, giving us -10 for the second one. And your final problem, let's see, we have a negative, but this is positive. Alright, so that means that both of these should be a negative number. And I'm thinking 3 and 4. 3 times 4 is 12. 3 plus 4 is 7. And they're both negative here. Alright. Let's see. X minus 3 equals 0. X minus 4 equals 0. And then we'll just solve. I got x equals 3 for the first one. And x equals 4 for the second one. Alright. So you notice that general factoring, it's not any different than what you've done way back in the review unit, or even back in geometry and algebra 2, or sorry, algebra 1. This is algebra 2. Anyways, it's not any different. The only thing that we added that's different here is this final step of taking each piece, setting it equal to 0, and solving. So if you remember how to factor this part of solving, pretty easy. Just don't forget, you have all different ways they're going to ask you for it, right? Zeros, solutions, roots, okay? Keep those in mind and you'll be fine. See you at the next video.